Hello everyone, thank you for joining me today. My name is Lisa Jobson and I am a technical specialist with IBM Canada. What I'd like to talk to you about today is blockchain and where IBM Systems are. We're going to take a look at what blockchain is and why it's going to be considered one of the largest disruptors since the internet, why it's very important because it's going to propel us into the future, and where IBM Systems are. Businesses, people, things don't operate in isolation, but that's exactly what's happening today. We have separate companies, separate systems, and separate information. Companies who are exchanging information, transactions, data, are all working with their own systems, and we have to send data, receive data, translate data, spit it back out to another organization. This is very inefficient because a transaction is recreated for every participant. It also makes it vulnerable to an incident because if there's one mistake or error in one organization, it can get propagated along the entire transaction train. This is also expensive because everybody is recreating the technology at their end, and there's also intermediaries required. Blockchain really shifts that paradigm. Instead of having discrete organizations, we have everybody working together. We have something called a synchronized ledger. So this ledger, or database, is propagated to every node in every one of those organizations. So it's an exact copy, and everybody has a copy of that. Transactions, as they occur in the blockchain, get bundled into a block, chained together, and then propagated out to all of those nodes. So let's talk a little bit about Bitcoin. Bitcoin is a cryptocurrency that's built on blockchain technology. And like any new technology, it's receiving some bad publicity. Let's take a look at where the internet was 25 years ago. When we first had the internet, it was just a bunch of chat rooms, and people said there was just going to be pretty pictures put up on the internet. They really didn't foresee all of the business that was going to happen on the internet. Now, there were some technologists that theorized that we would actually socialize on the internet, and they were laughed at. These same technologists are theorizing that blockchain will be even bigger than the internet. Why? Because it is actually going to bring online people that haven't been able to access the internet or the applications there. The technology with smartphones, etc., is now in place for that. So blockchain is to Bitcoin what the internet is to email applications. So it is the underlying technology. Bitcoin is not a company. It doesn't have a CEO. It's not in one country. It's by the people, for the people. And it is a cryptocurrency that you can purchase things with. Now, in 2008, this was started as a white paper by an anonymous individual or organization. The white paper was translated into open source code, and that became Bitcoin in 2009. The very first transaction was the purchase of 2 pizzas for 10,000 Bitcoins. If you were to have those 10,000 Bitcoins today, you'd have $8 million because 1 Bitcoin is worth over $800 Canadian. Bitcoin's failures are being extensively reported in the news, but let's be realistic. It's not like I can't use cold hard cash to anonymously buy something that Bitcoin's being accused of in the media. And really, very large organizations are taking a look at cryptocurrencies. For example, Bank of Canada announced in June that it is investigating and testing a CAD coin cryptocurrency for the Canadian currency. So why is it important? Well, really, blockchain takes us from the Internet of Things to the Internet of Money, or the Internet of Value. And there's a lot of talk about how that's going to change business. A lot of people say that the middlemen are going to be pushed out of the way because the transaction with blockchain technologies is between you and your buyer, or you and your seller. My view is that the middleman will change. Companies poised to adopt blockchain will change the way we do business everywhere. And let me give you an example of that. Ripple is an organization that created a blockchain application to allow banks to directly transact without intermediaries. A Canadian bank sent a German bank an overseas payment in seconds. And today, with systems in place, that takes days. because again, we go back to the separate companies, separate systems, separate data. Blockchain is going to eliminate all of that. Blockchain value directly aligns with the IBM server values. One of the things that they say about blockchain is it's going to save time. Transaction time goes from days to seconds, just like in our example. It removes cost, the overhead, the cost, the intermediaries. It reduces risk because there's less tampering, less fraud, less cybercrime, and increases trust through processes and record keeping and having multiple copies. Now, isn't that the pillars of IBM Systems? Isn't that part of the roadmap that we've been delivering to our customers for the past 10 years? Remove costs with reduced cores, reduce risk with the highest security compliance in the industry. So let's take a look at some example use cases. We're going to take a look at land and property. Nearly 60% of land is undocumented in Honduras. And that's not only true in Honduras. That does happen in other parts of the world, where there's no record of proof who owns the land, and your piece of land can be possessed by somebody else. In the US, the problem is a little bit different. Subprime mortgages comprised of almost 36% of mortgages and mortgage-backed securities. So who owns the mortgage and who carries the risk on that mortgage? Having all these different transactions, all these different links in the chain made everything increasingly disputable and very hard to follow. Another good example is Internet of Things. So Internet of Things, which means objects or things have a presence on the internet, is a beautiful example. You can use a blockchain application to tie in things like your smart fridge, your wallet, your car. Just take a look at the technologies that could come down in the future. One example that I like to talk about is driverless cars, which Google is testing now. Google also has an application called Waze, which is GPS and traffic reporting. When I'm in my car driving to work, I have Waze on. It will report the traffic to me and also ask me if traffic conditions are occurring. So this information is being fed up to Google Maps. This kind of technology is a perfect example of how we can take things like car licensing and completely automate it. So who's better to take over that infrastructure? When you think of what happens at a state or provincial level, we have to go into offices, we have to get our plates, we have to get our license. It's all paper-based when it could be completely automated. In fact, you could have it just shut down to an LED in the back of the car and not even have to worry about metal plates. So this really is what blockchain is going to be able to do, tying all of those different applications together and making our infrastructure much more streamlined. So where are IBM systems in this space today? Well, if you take a look at some of the building blocks or the building tools of blockchain, Golang APIs, RocksDB, consensus algorithms that are going to be required to have different or various ledger copies throughout the nodes, this really takes advantage of our enterprise servers. If you take a look at Systems Ed and Power and the roadmap that we've had for the last 10 years, it is built for blockchain. It's fast cores. We reduce how many cores that you need in order to run the applications, fast memory, and all of this is integrated at the bus level. So you've got a fully optimized system, onboard cache, and the crypto accelerators. This clearly shows that IBM has been thinking ahead and we have built the systems for blockchain. Now, if you take a look at what we're doing in the community, there's quite a few examples. The Hyperledger project, which is part of the Linux Foundation, is an open standard collaboration founded just last December. And its purpose is to advance blockchain technology and provide some of the technology. Take a look at the standards that are going to have to be in place for this. IBM is a premier member, and there are over 50 members today. We donated over 44,000 lines of code. And all of this code, the Hyperledger proof of concept code for IBM servers, is available on GitHub. If we take a look at the cloud level, IBM blockchain services on cloud are available for proof of concept using the Hyperledger fabric. This is hosted on IBM SuperVessel, China, which is an open power cloud platform created by IBM Research. We also have Bluemix Garages, which is a learn by doing environment. Think of it as playing around or tinkering around in your own garage. You get to play with Bluemix, run some demos, and see how all of this technology works. So we have Bluemix garages in London, New York, Singapore, and Tokyo, and they are available for IBM server technology now. And if we just take a look at current events, if any of you are attending the EDGE conference in September 2016, we are going to have several sessions on blockchain. Behind the scenes, IBM is also actively participating and representing Systems Z and Power in the emerging R&D space in blockchain. Making this code, base code available is very important, and we've been doing that via GitHub and Docker Hub, because we want to be the infrastructure of choice for blockchain. On our servers, Systems Z and Power, they have been architected for many years for really big data. We are very good at storing it, securing it, and actioning it. If you take a look at Systems Z and Linux One, which is the foundation of blockchain on our Systems Z technology, and also on Power, we have built connectors, secure connectors to things like CICS, IMS, DB2, Oracle, SAP, Enterprise DB. We also have crypto accelerators on the chip to accelerate cryptographic algorithms. Now, something that's on Systems Z and is coming in future releases of Power is something called elliptical curve digital signatures. And just to give you an example of what this does and how this changes the cryptographic space, the algorithms that we have today would be like boiling a teaspoon of water. With elliptical curve digital signatures, that'd be like boiling the ocean. So obviously, we're going to be in a very good space to have accelerators that can do this. And memory. We have very large memory spaces available on these systems. So what does all this hardware talk mean? Well, when you take a look at IBM servers, this kind of technology is going to run 40 to 80% faster with 1.5 to 7 times more throughput. And let's take a look at some of the compelling advantages of Systems Z and Power. All of the pillars that we've talked about are very important for blockchain. Security, which is built in, flexibility, things like little endian Linux and KVM, which will simplify the environment even if you're not familiar with Power. Performance and price performance is something that we've always taken a very good look at. It's a very highly scalable system with typically 4 times performance improvements over x86. And a lot of that is due to our high bandwidth memory subsystems, our large memory spaces, our very large cache, and the price performance of the servers. Also are the hardware accelerators. We have CAPI attached accelerators for flash storage, and also, as I mentioned, the crypto accelerators, which will improve the speed of the cryptographic algorithms. So all of this is tighter integration with the systems of record. So that could be talking to the systems of record or becoming the blockchain system of record. Blockchain running on Linux, on either Systems Z or Power, allows for co-location or additional blockchain capabilities. Let's take a look at a Systems Z example. Everledger is a company that tracks and protects diamonds, art, and other valuables through the supply chain. They want to protect the sellers, the buyers, the suppliers, and the shippers against theft and counterfeit. Systems Z, underpinned by Linux One, is ideal for this environment. A long-standing and rich history as a system of record, where authenticity, security, scalability, and performance are going to be absolutely critical. So which iron link do you think you want in your blockchain? And lastly, I'd like to finish up with something on blockchain. IBM systems are built for blockchain. And if we can take a look at the lessons learned from the internet, I have 3 pieces of advice. Dare to be first. Collaborate for standards, because open source is very important. Place your bets and invest your time now. Talk to IBM before your competitors get out there on the blockchain. Thank you.